All right, thanks for joining us today. So I'm sure you all have heard a lot about LLM today already, and this talk, no surprise, is all going to be about LLM. But we're going to focus on the infrastructure layers for hosting your LLM model. So when I say infra, I mean the layer that's providing and managing your computing resources. So for example, your GPUs, your networking layer, and your storages. So just a quick intro. My name is Yifei, and join me here on the stage, we'll have Alan, Bruce, and Lambo. And we are part of the infra team here at Anyscale. And our goal is to build this scalable and stable and also cost-effective fundamental layers for all your RAID workload. So if, for example, today at the demo, both the public endpoint and the private endpoint will be running on the infra layer that we're building on. So the agenda of the talk today, we're going to start just talk about why you might want to start thinking about hosting your LLMs instead of running it on somebody else's infrastructure. And then we'll dive into 3 of the major challenges we have ran into. That's around complexity, cost, and speed for hosting these large complex models and the solution that we developed to help address these problems. So before I get started, I just want to do a quick survey of the audience. So for the folks here, how many of you are already running LLMs in production? Okay, there are actually quite a few already. And it's kind of hard to see. So for the folks who are running in production, raise your hand again if you're using proprietary models, for example, like OpenAI, Cohere, Anthropic. Okay, a few folks. So what about open source models? Okay, more open source models. And are you guys running it using some third-party APIs? So you are hosting your own LLMs. Okay, sweet. All right. So as the open source model become more mature and just higher quality, we're seeing really growing interest in hosting these large language models in your own cloud infrastructure. So there's 3 reasons that we see that's the trend right now. So first of all, it's flexibility. So when you're using somebody else's third-party APIs, you're kind of limited to the models they're offering. And if your applications, say, have some performance requirement or some volume requirement, you're really constrained to the latency and rate limit provided by these vendors. On the opposite, if you're hosting this LLM on your own cloud infrastructure, your application team have the flexibility to choose what models they want and also to have full control of the weights. And moreover, it's really a strategic thing for your infrastructure team to start thinking about how to integrate these large language models infrastructure into your existing setup, right? Because developing an AI application is not just calling these API endpoints, but also you need to integrate well with your data preprocessing, embedding calculation, and all your traditional workloads as well. Second thing is data privacy. So data is going to be really important and crucial for your business. In addition to that, your customer might care a lot about data privacy. And they might just be regulations that's prohibiting data from leaving certain region. So when you're hosting this LLM in your cloud infrastructure, you really have control of where the data goes, and you can make sure if there's any sensitive data, they never really leave your environment. Last thing, and the most important thing, is cost, right? So as the usage for LLM continue to grow in your business, the costs of these are going to dominate your computing costs. You really want to start thinking of, hey, how can I cut down these costs instead of paying by tokens? Okay, so now, after we talked about why you might want to be hosting it, and the question becomes, how do I do this? And what are the challenges we might run into? So today, I want to talk about 3 challenges, starting with the complexity of managing this cloud infrastructure. Right, so as I mentioned earlier, you're going to have your compute, your permission layers, your networking, your storage, and you might need to do this across multiple clouds. So these all requires expertise and time, and your organization might not have the resource to do that right now. Second challenge is cost and GPU availability. So running this LLM workload, you're going to need specialized hardware, right? For example, like A100, H100 GPUs. These GPUs, they are hard to get, they're really expensive, and you're going to need a lot of them, right? So the question really becomes, how do I leverage my existing compute in the most cost-effective and automated ways? And the last thing is about slow boot time. Sometimes it just takes a long time to set up this machine. You need to set up your dependencies. You also need to load these giant models. And this really matters because it will show up when you're trying to auto-scale up, when your load spikes. It will also matter when you're trying to do your development work. As we saw earlier, it takes a lot of iteration to develop these LLM models. Okay, so now I want to invite Alan up on stage and dive into the first challenge and what we did.
All right. Thanks, Ife. Yeah, so as Ife mentioned, once you decide to self-host your infra in the cloud, one of the first challenges you run into is managing the complexity of cloud resources in your cloud provider account. So the first thing you might need is compute. So this is your GPU or CPU instances to run your workloads on. And this might be trivial and easy to set up for toy examples and experiments, but it can get quite complicated once you get more serious about productionizing. One of the things that you might be considering is networking. So this is where you set up how your nodes will talk to each other and how your nodes will access services outside the network and how you manage access control to the computes inside the network. And this is also where a lot of the privacy and security requirements will come from. And another thing that will come is storage. You will need it for logs, for weights, and all kinds of other data. And keep in mind that these things will grow as your features and team grow. The complexity also grow with that. So how does Anyscale solve that problem for you? If you're not very concerned about the specific about these configurations, Anyscale offers a one-command setup that helps you bundle all these resources together. As you can see, it's one command that sets up all these resources for you with the default configuration and gets you up and running in minutes. And if you're a team with a lot of existing infrastructure and then you really want to fine-tune your configuration to meet your own personalized needs and compliance, we also offer infrastructure as code Terraform for you to manage your own resources that way. To summarize, Anyscale Clouds, we offer you simple and flexible options to really speed up the setting up the overhead of infrastructure and then to get you focused on the problem that you're solving while meeting your compliance and requirements with ease. Thank you.
Thanks, Alan. So next, let's focus on, let's say, how Anyscale bring the intelligence for you about cost and GPU availability. So there are multiple dimensions for cost and availability. The first one is the market type, whether this instance is spot or on demand. And the second is the location, where it's located, like say which region or which zone. And the third is a cloud provider. Is that from EC2, GCE, or actually you have your on-prem machines, for example, on Lambda Lab or Kobe. And the last one is instance type, whether it's A100 or H100. So Anyscale provides you different kind of preference for the intelligence. One thing is you can say, I want to optimize the cost. Another thing you can say, I want to achieve the highest performance to finish my job as soon as possible. So today, let's focus on a case study about how we can optimize the cost without compromising the reliability. So here, as a customer, I want to start my Llama 2 serving model to serve LLM online. And I want to do it as cheap as possible. So with the cloud setup, you have some A100 machines on your Anyscale cloud, and you say, I need my A100 machine resource to launch my Llama 2. And you come to Anyscale, say, I want to start the Anyscale service. So with the cloud management, we know that you actually support 3 clouds, AWS, GCP, and Lambda. Let's say on EC2, you have P4D machines, which provide you 2 options, spot and on-demand. They have A100 resource. On GCE, you have A2 machine also has A100 resource, provide you spot and on-demand. And on Lambda Lab, you have your on-prem machines, which is on-demand, with a cheaper price than the other 2 on-demand instance. And the price here is for example. And So Anyscale can just monitor all the price for all types of instance. And it can also dynamically monitor, for example, the spot changes price. And it will figure out the ranked order for all kinds of instance. So here we can see the P4 on spot instance is the best choice. And let's say how Anyscale actually upscale and ramp up your service. So with the ranking, let's assume all the instance types are available at the first time. So Anyscale start your Anyscale service, and we'll try the best choice, which is a P4D spot instance. So now your price is $10. But as we all know, the spot instance is not that stable. It can be preempted. So here, let's assume the preemption happened. So P4 become not available. So AWS will give us, let's say, 2 minutes notification before it's really terminate. So within these 2 minutes, we will utilize this time to figure out the second best choice, which is an alternative. It can cross cloud provider, cross different instance type and region. And now we found the best choice. Second best choice is an A2 machine on GCE. So we will start that, and we have a faster start time, making sure it starts within 2 minutes. And we do a graceful join from P4 and to migrate the traffic to A2 without any loss of the traffic or any failures. So let's say after 2 minutes, the P4 machine finally got terminated, but we already fully switched to A2, and now the price is 12. So let's assume, okay, A2 is also a spot instance. It also gets preempted and not available. So we will do the third best choice, which is a provisioned instance that you register by yourself, which is the Lambda, and we can use it. So we switch to Lambda Lab and use the same technology as the graceful join. So there's no failure, and now our price is $15. So after that, the beautiful of Anyscale is that it can just monitor the availability dynamically. Let's assume after a while, P4 spot instance become available again. So Anyscale can detect that and try to start the P4 instance again and do the same graceful joining and switch back to P4 instance. So you can see with this intelligence, the Anyscale can achieve the overall best price and optimize the cost always for you. And also, you will see no traffic failure, and it just happens automatically for you. So as a summary, what Anyscale automatically provides for you is try to leverage the spot instance usage as much as it can. And between all the switches for different alternatives, it's a graceful join, and you will see no track failure. And the last is that we also support, let's say, explore all those alternatives across cloud, region, and even on your prime machines. And for example, you can just have reserved instance on EC2, GCE, and Azure, any cloud provider, and you reserve them as on-prem machines, and we can manage it for you by just automatically. So next, we'll hand over to Lambo.
Thanks, Bruce. So now I will introduce how Anyscale tackles the slow cold start time. So cold start is a very typical problem that is in many service platform providers. It really means that the time spent from the user submitting the workload to the platform provider until the platform provider provisions the computing resources and eventually runs the workload. Fast cold start is very crucial to LLM workload. For example, it facilitates autoscaling for the LLM serving, such that we can quickly upscale the computing resource to meet the serving workload demand just in time. Instead of keep the computing resource provisioned for the peak usage and waste a whole bunch of computing resource when the traffic is off peak. It also accelerates our end user for their development cycle, such that they don't need to wait for a long time before the computing resource is ready, so they can do their work. So in terms of Anyscale, cold start largely involves creating a RAID cluster. For example, when user submit a batch job to Anyscale, so our control plane will launch VM instances in the data plane. The data plane is run in a customer's AWS or GCP account. After each instance is started, so they will pull the RAID container image onto each node and form a RAID cluster and eventually start a user workload. So we did a very close study end-to-end to analyze our cold start problems. And we found out that a large portion of time was spent on pulling the container image. So we used to run the Docker, and if you're familiar with container technology, starting a container usually involves first pulling the container image from the registry onto the local machine. And then there's a step to extraction, which extracts each image layers into snapshots. And then we mount the snapshots into the container file system, and then eventually start the container process. So our users usually use very large images because they install various Python packages that can be up to more than 10 gigabytes. So this pulling and extract process can take up to 5 to 10 minutes or even longer. So then we start to think about how can we bypass this expensive pull and extract step. And yes, we come up with this idea such as if we cache the image snapshot in the cloud object storage, we can directly pull the snapshot onto the VM instance and then mount them as a container file system and start the container process. So in terms of implementation, we switch to use Containerd. Containerd is an industry standard container runtime, which is used by Docker underneath. It also allows extensive feature extension via its plugin API. We implement our own Containerd snapshotter, which will build the image snapshot, upload to the cloud object storage for one time. And then we will pull the image snapshots invoked by the Containerd onto the VM instance. And they are immediately mountable as a container file system, and we start the container process. So this work has been rolled out since early this year for several months. And we also did a benchmark, and we see the 5x improvements, such as a single node start can be under 60 seconds. So many of our customers are very happy about this change. This significantly improved our user experience and the productivity. Thanks. I'll now hand back to Yifei.
Thanks, Lanbo. Okay, so just want to recap really quick what we just talked about. So we talked about why you might want to think about hosting large language models on your own cloud infrastructure for the reason of cost, privacy, as well as flexibility. And then we talked about the 3 challenges that we've encountered the most, as well as what we did to address them. So starting, we talked about how we handle the complexity of setting up and maintaining these cloud infrastructure resources, which we have basically infrastructure as code to manage these resources. And then we talk about how we cut costs as well as provide better GPU availability. We do these by leverage the spot instance as much as possible without compromising your services availability. We also can switch between alternative instance types to find whatever instance that's available to run your workload. And we also can support cross-cloud and cross-region RAID cluster. So basically, we can run your RAID workload wherever you can find your cheapest GPUs. And last thing is we try to speed up the node code boot time by implementing a customized container snapshotter and a customized container snapshotter file format. And we're able to improve our code boot time by 5x. So before I end this talk, I also want to point out 2 things. One thing is LLM inference is really a full stack problem. So today we focused a lot kind of on the infrastructure perspective, but really there are many layers above that also contributes to how do you serve your LLM model cheaper and better. So if you're interested in topic, for example, like speculative decoding, continuous batching, or model multiplexing, I recommend you to go to this talk tomorrow by our coworkers Tammy and Kate about how Reserve can enable you to do more cost-effective LLMs. And another thing I want to mention is when you develop your ML application, right? It's not just doing the inference part. It's really your entire software development workflow. So Anyscale as a platform, we also try to integrate really well with everything else in your standard development cycle. So this includes your CI/CD pipeline, and also how you have a managed jobs and services, how to have a better observability into your application, as well as just improving your development experience. So if you're interested in the tools that we built to help provide a scalable distributed development experience, I recommend to check out the talk by our coworker Sofian tomorrow at the same time in this room as well. Okay, so that's all we have for you guys today. Thanks a lot for joining us, and if you have any questions. Okay, I take that as we explained things very well. But we're going to be around, and also a bunch of the folks on the team. Please raise your hands up, infra team folks. Also in the room. So if you have any infra questions or just want to share about your infrastructure challenges running LLM or any other ML workload, please come find us and talk to us. Thanks again for joining us today. Thanks.